Hello my champions, welcome back to our channel Deeksha Karnataka. Today I'm here with your Masterstroke session for the chapter Application of Integrals. Okay, so let's talk about the weightage first. So there will be one question that can be asked from this chapter in your PU2 boards. That will be a 5 marker and it will be an easy question. Okay, whether it is a ellipse based, whether it is a parabola combination with straight line based, but yeah, it will be a easy problems over there as well. But when it comes to CET, 2 marks can be expected from this particular chapter. So weightage part is clear. It's a small chapter. It's a very low weightage if you consider the other chapters of calculus. The least of all the other 5 chapters, like total of 5 chapters from the calculus side. Okay, so still simple is there. Very simple integrations are used over here. Nothing very difficult or challenging nature problems can be asked over here in your syllabus. So we'll just deal with it quickly. A short class to complete our application of integrals. Okay, so let me start the session right now. Okay, so first thing is this particular chapter talks about area under the curve. Okay, so application of integrals, in this we are learning about what? We are learning about area under the curve. Now in this, as I mentioned, there are various combinations possible. Means they can be given only one function and we are supposed to find the area below that particular curve like this. So function over here is given as the function fx and they're asking us to find the area below the curve, the function fx. Okay, then what is the required area? ABCD is there. ABCD is there. So what you do over here is simply find the area of a rectangle. So where is the rectangle, sir? I can't see a rectangle. When you make this distance dx, can you see this distance dx? Can you see this width dx? When you make it very small, can you make it very small? This is a very small quantity, very small. Then what happens? Then the strip that you see over here, this particular strip, behaves and acts like a rectangle. Where this will be your y value, the length, and this will be your dx value. So what you do is basically multiply this two quantities. How you find the area of rectangle? Y dx. You multiply y dx. Okay, y dx. Then you integrate this y dx. What's the meaning of integrating, sir? Over here means how many strips as such will be there in the entire area ABCD. Think about it. We can have, sir, one strip over here. We can have, sir, one strip over here and keep going on. We can have strips like this. How many times we'll have? From the point x equals to a to the point x equals to b. Right, here the point is x equals to a, here the point is x equals to b. So I'll have so many strips from this point a to b. So if I add area of all the strips, I'll get my required area under the curve ABCD, and that's exactly what it is over here. Okay, so integrate this means add all the strips area from where to where? From A to B, and you end up with what? You end up with area under the curve, fx, or you call this in this case as ABCDA, or simply ABCD. You can check here ABCDA. Okay, sorry, yeah, ABCD is enough. Got it? This is how you relate to the application of integrals in area under the curve. I'll repeat again. So what does over here? What is the application of the integrals in this case? So we use the integration to integrate or to sum all the areas of these small strips, which is acting like a rectangle, and this is how you find the area of rectangle. Y into dx, integrate from A to B, you get all the sum of all the areas under the curve fx. Okay. Yes, sir, it makes sense completely. Now we have understood. Now in this we have some special cases. So what we deal with over here is they might give you a function, they might give you a shape, they might give you a definite integral problems based upon ellipse, based upon parabola combination with straight line, and ask you to find the area under the curve or area of the intersection of the curves. Okay, do not worry, I'll show you some special cases also, and I'll show you some examples as well in this class, even though it's a concept lecture, but I'll show you that as well right now. Later, of course, when we come and practice questions, there I'm going to practice more questions in different varieties altogether. Okay, so can we move on now? I think basics of where the application of integral works in area under the curve is clear now. Okay, let's continue. Now before I start, I have a surprise, I have a gift for all of you, and that gift is very simple. So like this of the lecture is out, right? The integration lecture for the Masterstroke is out. So in that lecture also you'll find it, in the today's lecture also you'll find it. So today's lecture is what? Your application of integral. So in both the lectures, all the lectures that is coming your way from our channel Deeksha Karnataka, you can simply go and check the description of the video. Then you're gonna find 4 free KCET mock tests. Yes, 4 free. Check here, because we understand the importance of the time right now and how crucial it is to solve the mock test. So we asked the management and they have arranged something like that for all of you. It is 4 free KCET, 1 for physics, 1 for chemistry, 1 for maths, 1 for biology. You can attempt the maths mock test today itself, right? Because I'm a maths teacher, I would like you to practice some more maths question. And if you check over here, I'll have here mathematics. Go ahead, click the link, you will get something like this. Simply fill your details like numbers and continue with the login, and then you can simply get the access of the PDF. Okay, so download this and attempt it today. Okay, or you can just simply log in with the mobile number and OTP. Okay, so this is about your free mock test. Let's move on to the chapter now. So free mock test, you've got surprise, the gift you got. Go ahead, practice it right now. Okay, now a few combinations I want to show you. So look at the graph over here. Now this is if you try to find the area under the curve for fx in this particular case, of course it'll come out to be negative, because this whole thing is what? It's a negative value, it's below x-axis. But area, have you seen ever an area to be minus 35 square units? You've never seen that like that. Okay, so whenever you find a negative entity for the integration, but you're dealing with what? You're dealing with area under the curves, then of course you'll have to apply the modulus. Okay, now this is a case where the area is coming as negative. Now this case over here has both the parts. One of the area part, if you take in total, this part of the area is positive, this part of the area is negative. Below the x-axis is negative. So what you do in that case is, where it is negative, you apply modulus. Okay, means I can distribute it from A to C and C to B. So A to C you don't have to multiply. Check here, A to C you can keep it like this, beta. No change, no need to apply modulus. But for C to B, for C to B you'll have to apply modulus. And why you see a minus sign over here? Because this integration will come as actually negative. To make it positive, you're gonna introduce a minus sign. That's what it means. It's not negative actually. This whole entity will be positive only. It'll be positive only. Okay, moving on. So simple 2 cases where the area is negative, and you know how you make it positive by using simply modulus. No need to worry about anything. Sir, my answer is coming as minus 44. The answer is actually 44. Don't worry about it. Okay, I'm just giving you an example. Now, area of a region bounded by a curve and a line. How to draw it, how to plot it. So simple. If you can draw neat and if you have time, then try to go ahead and draw actual graph. Otherwise, sketch a rough graph. Sir, how do we draw a rough graph? We know the different functions graphs, right? We have learned in relation function, whether it is a linear function, whether it is a quadratic, whether it is parabola, whatever it is, whether it is circles. We know how to plot those graphs. We know the key points, vertex. We know the like foci. We all know all these cases. So draw a rough sketch of the graph or the function given to you. Now, once that is given, of course there'll be straight lines, some other functions. So find the points of intersection. Okay, where between functions and also with what? With the coordinate axis. With the coordinate axis. Why it's important? Because then only you get to know what? Then only you get to know the limits. Excuse me. Then only you get to know the limits. What limits, sir? Both upper limit and the lower limit for definite integral. So that's the next step. Set up the definite integral. Once you know the limits, once you know the function, simply set up the definite integral, and the last will be integrate and evaluate. If it is coming negative, apply modulus and give the answer. Okay, getting it? Clear? Simple? All right, sir. So this is clear. This is the steps. I have given you 4 simple steps to calculate or to solve any questions area under the curve using of course, application of integrals. Clear? First is sketch the rough graph. If not rough, you can draw properly. Do that. Find the points of intersections with the between the functions and as well as with the coordinate axis. Set up the definite integral and integrate and evaluate. Okay. Now, so I know by now most of you, every one of you have already taken it, but if somebody has still missed out, do not miss out to take ABHYAS KCET test series. It's very important, very important, equally important to anything that you're doing to prepare for examination. Let's say you are going and studying 8 hours per day for KCET, you're solving 100 questions of maths per day. This is equally important, more important actually, to your preparation of CET 2026. Okay, this is an online test. This is the online test, beta. You get over here 35 mock tests. Take the 4 free mock tests today. It's recommended by your seniors. They made this choice and they got this outstanding result. Many more were there. We can't show all the names over here. So there are few that you can see on the screen. Prajwal with the rank, the top rank of 171. And the price for this one is at 1499. Do not forget, this also includes your free, your bonus chapter wise KCET PYQs. I know you have solved the PYQs already, but have you solved like KCET examination? Did you ever solve a PYQ like a KCET examination? No, you have not. So that's why we have brought this feature in this test series, which is a actual real-time exam conditions are there. I mean, this is a real exam pattern, the KCET exam pattern and timing based online test. So in this you get PYQ also as test. Okay, last 10 years PYQs are taken over here. So do not forget to make the right choice and take ABHYAS today. Okay, now in the knowledge hub today, I have brought some key points which will help you understand and analyze how to make these sketches of the given functions. Okay, not a lot because you already know how to draw modulus function, different type of function you already know how to draw. I have taught you all that in the past, but today I have taken some points. Let's figure out. So what are those pointers? If the equations of the curve contains only even power of x, if we have even power of x, then the given curve will be symmetrical about y-axis. I know it doesn't make sense right now, but you'll see when I show you a question on this in this class itself. Okay, if equation of the curve contains only even power of y, then it curve will be symmetrical about x-axis. Okay, if the equation of the curve remains unchanged when x is replaced by minus x or y is replaced by minus y, x replaced by minus x and y replaced by minus y, then what it means is it will be symmetrical about origin. Means if it is in first quadrant, then it will go to the third, second to fourth. Okay, so symmetrical about symmetrical in the opposite quadrant means about the origin. Okay, now if the equation of the curve remains unchanged, if you replace x by y and y by x, it means symmetrical about the line y equal to x, means domain and range are interchanged even though the function does not change. So the functions are actually mirror image about the line y equal to x. This is your line y equal to x. Okay, what it does is simply makes the function change its this nature from domain and range will be interchanged. Okay, inverse of each other. Let me erase the markings, not important over here. Okay, sir. So let's solve some questions on it, some basic questions, how the question has been asked in your examination, and based upon that we'll have the learnings, applications, and then I'll show you at the last some special cases of parabola combination with straight line, which is very important. I'll show you. Means that formula you can remember. It'll help you how to, how can you score marks faster and easier in the CET. Okay, let's solve this question first. Find the area of the quadrilateral formed by the lines. Okay, so we have to draw the curve, x-axis, y-axis. Y equal to 2x plus 3 is the curve like this. Correct, no? This is my curve. This point is y equal to 3. This point is minus 3 by 2 is your x. Correct, no? X value will be minus 3 by 2. Y will be, when x is 0, 3 only. That's my curve. Other one is y equal to 0 means this one. This represents y equal to 0 curve. X-axis, that we all know. X equals to 2 and 4. 2 and 4. So what is my required area, beta? What is my required area? Check here. This is my required area. This is my required area. How do you find that? So basically integrate the function y dx from where to where? From 2 to 4. Check here. Dx represents the variable of integration is x over here. So the limit will be on the variable x only. So x equals to 2, x equals to 4 is the correct limits. Okay, very important to know that. Usually what happens, we make this mistake. We take some other variable as our variable of integration and we change some other limit. Okay, check here. The variable of integration is dx. So the limit is on x. Y value is what? Y value is 2x plus 3. So replace this 2x plus 3 with dx from 2 to 4. Integrate now. Integrate now, you'll get this as 2x square by 2 plus 3x from where to where? 2 to 4. 2 and 2 cancels. Put here 4, you get 16. Put here 4, you get 12. Put here lower limit as 2, you will get 4, 3. So 6. So 12 minus 10, that is 2. Answer is coming as 18. Answer is coming as 18, which is option B. Which is option B. As I mentioned, a simple curve given to you, just draw a rough curve, find the limits from the curve, find the required area which is under consideration, and get the result by simply applying or forming the conditions for a definite integral, integrate and get the result. Answer is option B. Next one, the combination of parabola and a line. What is the parabola over here? Y square. Y square means symmetric about x-axis. Is this of the form what? It's of the form y square equals to 4ax only. If you remember, a value is in this case 2, of course. It means it is passing through what? Origin itself. So this is my parabola. Okay, and the line is x equals to 2. The line is x equals to 2. What is my required region then? My region is very simple. Have a look. This is the region. This is the required region. I can find this area itself. I can find this area and get the required area, capital A, as twice of A, because they are symmetric in nature. Parabola is symmetric about x-axis, right? And if you take this line x equals to 2, these two parts are going to be equal in nature. So this area will be twice of A. So how to find area? Check. Limit is given for x. So y dx from where to where? From 0 to 2. Y dx, integration of the function y. I'm talking about only this function, okay? This function is y, and this is going to be what variable? Dx from where to where? X equals to 0 to the point x equals to 2, okay? Twice is there. Integrate now. Y value is, from there you can check, root of 8 root of x from 0 to 2 dx. Take the constant outside, you'll get 2 root. Integrate root x, you'll get x power 3 by 2 by 3 by 2. From where to where? From 0 to 2. Bring the constant outside, you'll get 4 root 8 by 3. Integrate, put the value of 2 over there, you'll get 2 power 3 by 2, put 0, you'll get 0 only. Yes, this is again root 8, so we get 4 by 3 root 8, and this value is also root 8. 2 power 3 by 2 is also root 8, so it will become 8 into 4, so 32. Answer is 32 by 3. 32 by 3 square units, of course. So my answer is clearly option B. See, whatever I taught you so far, I'm using the same thing to solve the questions, okay? And the questions in CET will not be very much different or difficult than this one. It will be of the same nature. It will not be of difficult nature or very much stranger to this. No, it will be of the similar category. So please pay attention. When I'm telling you, this is how you approach a problem. This is how you get the limits, draw the curve, and get the final answer. Then please follow this method. Do not think otherwise. If you have a doubt, put that in the comment section and ask me right now, okay? If you're watching me for the first time, do not forget to subscribe to the channel and keep the notification bell on for all the classes. If you miss right now, you're losing marks, as simple as that, okay? Very serious time. We got to be on our toes all the time to get the maximum result from here, okay? So you have to watch all the classes, ask all your doubts, and I'm here to support you all in all the way possible, okay? Don't worry, I'm not gonna give up on you. I'm not gonna, just ignore you. It will not happen. I'm gonna make sure that you all your queries are answered, all the questions are answered. So ask as many as possible in the comments. Okay, so as I mentioned, I have taken 2 questions. This was a theory class, but still I wanted to take some concerns, some questions over here, so I've dealt with that. Small chapter, not much is there in this chapter for your syllabus especially, so I've dealt with important things. Now I wanted to give you some special cases, important curves. Check here. So if you take a combination of parabola with a straight line, okay, what curve is this? Y equal to mx, means passes through the origin, that curve is there. The area of this is given by 1 by 6 m square by a square. M represents the slope of the curve. This is the slope of the curve m. Okay, a straight line. A square is the coefficient of, basically you are coming from the condition y equal to ax square, the parabola, coefficient of x square. Okay, great sir. I hope you can see that x square means symmetric about y-axis. That much we know. All right. Over here we have only one part as my feasible region, the shaded part. Over you can see that clearly. I hope you have joined the WhatsApp channel. You'll get the class notes over there only. Okay. Next, if you go ahead and include y equal to mod x, y equal to mod x. So see, the area of the region is between what? The mx and the parabola. Mx and the parabola. So you'll have 2 regions over here. You'll have 2 different regions of the same shape. You can check here. This, if you multiply with 2, m square by a square, and multiply this with 2, you're going to get this value as simply 3, and that's your answer. M square a square by 3 is your answer. So this is what you have to remember. For these type of graphs and cases, simply formula will give you the result. You don't have to solve it in the exam. Okay, please check. Alright, these are all derived formulas. The coordinates are there for the given points, point A and point B, that you can mention, that you can go through once you download the PDF. Next, if you have the parabola reversed, okay, means the now this is symmetric about x-axis. Alright, y square equals to 4ax is symmetric about x-axis, and the curve is mx, and mod of mx, same result, 8 by 3, 8 square by 8a square by 3m cube. Over here, check this out, in this case remains same, because even though we are using mod x, the other part, the negative part, does not have any intersection with the parabola, because parabola is what? It is concave towards right. Okay, concavity is towards right, means parabola is symmetric about the x-axis. There is no intersection of the parabola with the line y equal to mx. Okay, so even though we are using modulus over here, the area remains same. Clear? 8a square by 3m cube is the answer. A square is what? The coefficient of y, for the case y square equal to 4ax, okay, and what is m? M is the slope of the curve. Okay, so curve equation should remember, and the curve form, you get the final answer directly if you remember these conditions. Okay, now this will end your class today in AOI. Okay, I have kept things to the point. You don't have to get distracted too much over here. It's a simple chapter. 5 mark questions from ellipse, from parabola comes in our syllabus. I've taught you ellipse questions so many times, that's why I've skipped over here in the concept lecture, but if you want, I can solve that question also in our live class. Okay, so that is clear now. So with that done, the session is complete for AOI. Let me know your feedback, what you feel for this class in the comment section. Anything else you need from me, again put that in the comment section. Do not forget to do not forget to take ABHYAS right now. It's very, very important. And one more thing, I have seen some comments in the previous live where you all were asking me to help you prepare properly, or maybe not properly, means a more synchronized, more structured way. If you want a preparation like that, let us know in the comment section, and we'll come up with something. We are trying something from our side, and we'll try to get it soon on our platform for all of you, to help you prepare for your boards, for your CET. Okay, so with this, the class is over today. In this particular session, I talked about your AOI for PU2 and for KCET. I talked the concept part. I talked about what is it that it means when we talk about area under the curve in the application of integrals. Okay, so this ends the class today. I'll see you in the next one. Till then, take care. Bye-bye.